statistics tells the degree and direction of correspondence between two variables. In this example, when I am saying that this is, say, representing stress and this is representing health, when health, when stress is increasing, we are observing that health is going down. When, sorry, we earlier take the example of job satisfaction. If job satisfaction, I will take that example later. Let us see stress. If stress is increasing, the health is going down. If stress is decreasing, health is becoming better. So there is a correspondence. If this is moving, this end is also moving. So two ends or two variables are having a correspondence. Covariation. If one is varying, the other is also varying. This is also called covariance. But the direction of covariance is opposite. Now take the example of job satisfaction and mental health. This is job satisfaction and again this is mental health. If job satisfaction is decreasing, the mental health is also decreasing. If job satisfaction is increasing, the mental health is also increasing. Again, there is a correspondence between the two scores, the mental health variable and the satisfaction. But this time, the correspondence is in positive direction, in the same direction. If one variable is increasing, the other is also increasing. So this one, the stress health relationship, is suggesting that stress is having a correlation with health, but the correlation is negative. So correlation is of two types. Positive correlation if the correspondence is positive, and negative correlation if the correspondence is negative. And the only condition is that we can compute correlation when the two variables are having some covariance. यदि एक वेरी कर रहा है तो दूसरे में वेरिएशन होना चाहिए. Suppose this example, I am varying this, but you can see the left side of the pen, it is constant. I am decreasing this, no change in this. This is the example of zero covariance, that is zero correlation. Suppose now I am fixing this. If I am increasing this, this is fixed. If I am decreasing this, this end is fixed. So if one variable is changing, varying, but there is no corresponding variation in the other, it means there is no covariation between the two variables. If two variables are not having simultaneous covariation either in negative or in positive direction, then there is no correlation. So basically correlation may be either positive, negative, or zero correlation. Now I will discuss how to, and this example is example of bivariate correlation, because I am having only two variables, stress and health, job satisfaction and mental health. So how to compute correlation? So I will share my Excel sheet and I will create one very simple example to explain the computation and their formula. So bivariate correlation, in your syllabus, we are having two types of correlation. One is called product moment correlation. This correlation is calculated when the two variables are measured on interval scale or higher. Variables can be on nominal scale, ordinal scale, interval scale, and ratio scale. So when variables are having continuous scores and measured on interval and ratio scale, then we compute generally the product moment correlation, and this is the formula. And when the exact scores are not known, or the variables are measured on ordinal scale. So, for example, I know your maths and statistics rank. You are having first rank in statistics, but second rank in mathematics. Someone is having fifth rank in mathematics, but first rank in statistics. So, we are having only ordinal scales, ranks. Then the correlation can be computed using the method called rank order, and this is the formula. This symbol is read as rho, and this is a small r. So small r is used, lowercase r is used to represent product moment correlation, and rho is used to represent rank order correlation. And this method is given by a researcher called Carl Pearson. So it is called Pearson's correlation coefficient. And this method is given by Spearman. So it is also called Spearman rank order correlation. So this correlation is associated with Spearman. Now let us have two variables, and I am increasing the font size and making it bold so that it is more visible. And let us assume that there are two variables, x and y. And I am putting just a few scores, say x is 10, 13, 9, 6, 12. Let us have 5 scores so that we can do the demonstration easily. And nine, then 10, then 7, then 7, and then 9, or say 11. I am just creating two scores. So if these are the two scores, x may be any variable, say mental health, stress, or anything. Y may be any variable you can label. And if you are having two scores, the scores are continuous, and therefore we can, now I am putting off my camera. So we can compute the correlation using product moment method or Carl Pearson method, R. So if you can see this formula, in this formula, we need the sum of the product of these two variables, x, y. So first column that we need to calculate for computation is x, y. And then no other column is required. So what is x, y? So it is the product of x, 10 into 9 is equal to 90. 13 into 10 is equal to 130. You can do it. This is simple calculation. 9, 7 ja 63, 42, and 132. Now, when we will add this variable, this is 457. This is basically the summation xy. This is summation xy. देख रहे हैं ना आप लोग?
Yes, sir.
हाँ जी सर.
Now, if we will add this, then the resultant value will be called summation y. And if we will add the column x, the resultant value will be called summation x. So 50 is summation x. So in this formula, we need summation x, summation y, summation xy. What else we are missing? Here you can see summation x square, and here you can see summation y square. So one thing we are missing. So we will create one variable x square and y square. So x square is equal to 10 into 10. So 113, So this is x square, and when we will add this, this will be value of summation x square. Now similarly, we will square the value of y. So 9 into 9 is 9 square. So y square, and let us drag this, and when we will sum this value 400 will be the value of summation y square. Now one thing we are still missing, that is this n. Here n is not that you will say that 5 and 5 10. N means here n is equal to number of paired observations. So how many pair? 1 pair, 2 pair, 3 pair, this is 4th pair, and this is 5th pair. So here let us put all the value. N is equal to 5. Summation xy is equal to 4, 5, 7. I am just writing exy. You assume that it is summation xy. 4, 5, 7, summation xy. Summation x is equal to 50. Summation y is equal to 44. Summation x square is equal to 530, and similarly y square is equal to 400. Now if we put this in the formula, r is equal to, then we will do first n into summation xy. So I am doing calculation to show. First I am computing numerator. Okay, so n is 5 and into summation xy is, take the value from here or from here, it is 4, 5, 7, and then from this we will subtract the value of summation x, that is the product of summation x and summation y, that is 50 into 44. And when we will do, now let us do this using formula. So this will be 5 into 4, 5, 7, bracket closed, minus 50 into 44. Let us do this. This is coming to be 85. Now similarly we can do the computation of denominator. In denominator we will have to do two computation, one for x. So ये क्या है, n is equal to 5 into summation x square. Summation x square means not 50 square. It is the value of this column. So summation x square is equal to 530. And the second term is, sorry, this is incomplete. This is 5 into 530 n into summation x square minus summation x whole square means 50 whole square. So minus 50 into 50. And the second term is 5, look here, n summation y square. So y square sum is this. So 5 into 400 and put the bracket, and then minus summation y whole square, and summation y whole square is 44. So 44 into 44. Now let us do the computation. So if we are doing this computation, so I will put is equal to one bracket, then another bracket, 5 into 530, bracket closed, minus 50 into 50, and then bracket closed. If you are writing this type of formula, count the brackets. From this side is 1, 2, and 3. From this side there is 1, 2. So we will put one more bracket and then enter. This is the value 150. Now let us do the computation of this. Put is equal to sign, then double bracket, 5 into 400, and then minus 44 into 44, and then close the bracket. This is 64. Now you have denominator. So numerator is 85. Denominator you are having two value. Now let us compute R. So R is equal to, in numerator it is 85 divided by square root of what? 150 into 64. I have done all the computation. I have computed this at one time. This one, the x term one time, that is 150, and this term another computation 64. So this is the value of R. And now let us do the computation. So if we will do the computation, it will be is equal to 85 divided by SQRT square root of 150 into 64, bracket closed. So this 0.87. This value indicates, since this value is positive, this, and remember that correlation will always lie from -1 to +1. So perfect positive correlation is +1. Perfect negative correlation is -1. And this is very close to 1.87. So we can say that X and Y are highly correlated. The correlation is 0.87. And just to check whether we have done the computation correctly or not, you can do it by Excel. It will not. So you type correl. Correl means this is the function for correlation. Then put the, it is asking array 1. This is the first score series. Comma. This is the second score series. And then close the bracket. Look, this is computed directly using the statistical function, but we have done the calculation manually and both are same. So you have now developed a confidence that you know how computers and software do the correlations. Any question or any query? This is the calculation of product moment correlation. कोई प्रश्न है किसी को? कोई है भी कि नहीं? मैं देख नहीं पा रहा हूँ. 26 लोग, 25
No,
लोग.
sir. No.
Clear है ना? And
Clear है, sir.
I am doing recording, so I will share
Yes,
this recording. And I will also share the recording of standard deviation, but this will be shared privately. I will not make it public YouTube video because recording quality is not that good. Okay. So I am having some request that to upload good quality, but I will upload it and it will be privately shared to all. Okay. So let us proceed to the next calculation, and it is very simple. I am just taking this score series alone, okay, and demonstrating this for rank order correlation. Here you can say the rank order correlation is determined by row. It is very similar to small lowercase p, but it is somehow rounded and it is Greek letter row. If we are having two score series, rank order correlation will be calculated by rank score. So we need to calculate. Let us increase the font size and boldness of some area so that you can have some idea. So product moment is required for the rank score. So if we are having rank score of y and x, then we can use this. But sometimes in examination, the raw scores are given and the examiner asks to compute rank order correlation or Spearman's correlation. Then we will have to rank the x and y series, but do not sort it. We have to do the ranking in this position itself. We will not change the position of the score. So we can generally we provide rank 1 to the highest score. So if you can do in any way. You can provide rank 1 to the lowest score also. But if you are doing so, do the same thing with the y score. ऐसा नहीं है कि x में highest से शुरू किया और y में lowest से. So follow the same. We all know that we provide rank 1 to highest scorer. So in this example, the rank 1 is 13. 12 is having rank 2. And then the rank 3 is 10. On 4th rank, the person who is having a score 9 will come, and who is having a score of 6 will be getting 5. Now come in this rank 1, this is the highest. Rank 2, this is the second highest. Rank 3, this is the third highest. Now here we are having a tied rank. There are two individuals having 7. So in this situation, what we will do, we will mentally provide that this one is having a rank of 4 and this is having a rank of 5. And then we will get the mean of the ranks. So the 4 plus 5, 9, 9 divided by 2 is 4.5. So we will not say that this is fourth and this one is fifth. We can also not say that this one is fourth. Let us give the mean rank to both. So this is 4.5 and this is also having 4.5 rank. So if you get in questions tied rank either for X or for Y, you can do the ranking in this way. Now, for computing correlation, if you will remember my example of the pen, it is the degree of correspondence. So if we get the difference between the scores or rank, we can say if there is no difference, then there is correspondence. Larger difference, then there is no correspondence. So D is basically, D is equal to R, and it is, you can do anyway, Rx minus Ry. If you will write Ry minus Rx, it is not going to matter. So, and I am increasing the width of this, so you can see the formula. So Rx minus Ry, so 3 minus 3 is equal to 0. 1 minus 2 is equal to minus 1. 4 minus 0.5 is equal to 0.5 or minus 0.5. 4 में से 4.5 घटाने पे कितना आएगा? Anyone?
minus
Minus
0.5.
minus 0.5.
Very good. This is your support to me. I feel really happy when you speak something. 5 minus 4.5, it is 0.5. Very good. So now the final, you see the formula. It is summation D square. So we need one score more, one column more, D square, D raised to the power 2. So 0 square is 0, minus 1 square is 1. Therefore, I said when you are having a squared value in use, if you are subtracting Ry minus Rx, it is not going to affect. So forget, do not stress yourself. 0.5 का स्क्वायर करेंगे तो 0.25. Is it correct? 0.25. And if we will sum this sum will be called summation D square. So now compute rho. It is pronounced like this. Rho is equal to 1 minus, then put in bracket 6 into sigma D square. D squares, we will not square 1.5. This is the value of sigma D square, 1.5 divided by n into n square minus 1, and n is number of paired observations. So 5 into 5 square is 25. 25 minus 1 is 24. 24 into 5. Can any one of you calculate?
120.
Very good. 120. So this is the row. Now do the computation using Excel formula. So we will write 1 minus, then in bracket, 6 into 1.5, bracket closed, divided by, then bracket 120. I am putting bracket for safer side. So 1, 2 and 1, 2. So this is 0.93. So this was 0.87 and this is slightly higher because we are working with rank score, not the actual score. So this is the computation of rank order correlation. Any question or query? So, based on this, if we are doing prediction, okay, if we are interested in predicting the value of X or Y, I will share the PPT first and then I will come here. I am stopping this screen, then I will share my PPT. And let me set my PPT. Slide source. So I am sharing this correlation and regression PowerPoint. Can you see the PPT?
Yes, sir. You're
Yes,
audible.
sir.
Okay. So I will be moving fast and I will focus on the computation only because from examination point of view that is more important. So basically when based on regression or sorry correlation, if two variables are correlated, मान लीजिए हमको मालूम है कि जब जब बादल होता है बारिश होती है. So if you will see clouds in the sky, you can easily predict, sir, it is likely to rain. Similarly, if two variables are correlated, we can predict the score of one variable based on the score of the other. And the model used for uh, making this prediction is basically a general model. You can say the outcome, say y is equal to a model plus error. And generally, we fit a linear model. So, a linear model, you all have learned mathematics up to high school. So a simple line is represented by y is equal to a plus bx, and b is called the slope of the line and a is the constant. So this is the simplest regression equation. If we have to predict y, then we can use a. If we know the constant a and if we know the slope of the line, then putting the value of x, we can say suppose x is height and y is weight. If you have to predict my weight and my height is say 5.6 inch, and if you know the values of a and b, a is called intercept in the regression term and b is called regression coefficient. So using this equation, we can do the computation. And I will show how not to learn very difficult calculations. I will show it in a very simple way, how to learn it by heart without going to rote memory. So this is simple regression equation. And this is the situation. Suppose I am presenting these scores. So if this is x-axis and this is y-axis. If x is 2, if I ask you to predict what will be the value of y, someone will may say, sir, it can be close to 6 because there is one student having a score 2 and 6. Someone will say, sir, no, it may be 5. Better go with the lowest score 3 because everyone has scored 3 or higher. But the best prediction is that if we can calculate the mean of all these values, and this large circle is the mean, and if we do a series of, or you can call the moving average, if we are calculating mean for each and every point of x corresponding to y, and if we join this mean predicted value with a line, then we can predict. and even we can go beyond the data. Data is up to say 7 point something. If I ask if x score is 8, then what will be the value of y? You just draw a perpendicular drop here and then draw a parallel line here. You can say that it is likely to be, sir, 6.5. So we can make prediction by drawing such lines. So regression and correlation basically go hand in hand, and based on the values of correlation and some other statistics, we can write the regression equations and make prediction. So, and in this is the slope, this is b, this is the slope of the line, the angle that is created by this line, this is called slope, and this value where this regression equation or regression line is starting beginning on the y-axis, this is called intercept. Basically, intercept is the predicted y value when x is equal to 0. If x is equal to 0, even then y is having a score of say around 2.3. So this is 2.3 is intercept, and this intercept is called A. So in this we are having two values, and I will tell you very easily how to compute these two values A and B. So I am moving forward, and this is the regression equation. So this line is represented by or characterized by the equation y is equal to A plus bx. And these are the characteristics. So you are having different slopes, but sorry, different intercept. This regression line is crossing from 70, this is crossing around 40. So A is different, but you can see the slope is same. ढलान एक जैसी है. So B is same, but A is different. In this situation, both regressions are originating from the same point. So A is same, but this purple or whatever color you say, red, whatever you are seeing, is having a positive slope, and this one is having a negative slope. So slope is different. I am stopping here, and then I am coming to the computation part, and I will take only 5 minutes. And if it is not clear, then I will make another video and share it with you. So now I am going to present the Excel sheet again. And in 5 minutes, I will cover, because I have another meeting also, and that was scheduled from 4, but it is now quite late. So for regression computation, generally you will find that in examination mean will be given, say, and it will be given for the variable x as well as for variable y. So cut it here, put x mean, then standard deviation will be given, and then the correlation between two variables will be given. Say these two variables are having correlation of 0.5. Suppose mean of x is 30 and mean of y is say 54. ESD is say 7 and ESD is 8. So this information will be given in the examination, and you will be asked either to write the regression equation in the form y is equal to a plus bx, or to predict x on the basis of y score. If you have to predict x on the basis of y score, then this is called regression of x on y. And if I am asking to predict y on the basis of x score, then this is called regression of y on x. So there are always two lines of regression. One is regression of x on y, and another is regression of y on x. So just to help you to remember, I will start with, you can start with anyone. If we have to predict, say, x on the basis of y, so first you write on this side x, then put is equal to, and then what we have to predict? We have to predict y. Sorry. Oh, this is taking as different. Y is a, so if we have to predict x on the basis of y, so we will write x on this side and y on this side. Now, just I am telling the mnemonics how to remember. So we have, just remember what we have to do. Regression of x on y means we have to predict x and y score is given. So x will always be on the left side and y will be on the right side. Then you just put x bar on this side of x. So x है बाईं तरफ, तो x में से कितना घटाएंगे? x bar. और y में से घटाएंगे y bar. The only difference is that we will put b on this side. Now, I cannot write all the things, but I would request you to take a note. We can simplify this regression equation in form of y is equal to, or x is equal to a plus by. Then x is equal to by, and then when this x bar will come this side, by plus x bar minus by bar. And by bar, b is also a constant, mean is also a constant. So x bar minus by bar will be a constant. This constant may be either in plus or in minus. So we have obtained, this constant is basically the value of a. So x is equal to by plus x bar minus by bar, and x bar minus by bar can be called as a. So if you have to write the formula of a, then a is equal to, in this case, mean x minus b mean y. So x bar minus by bar is equal to a. And b we have to compute. And b is computed. I am just telling it loudly. You write the formula. B is equal to, this is regression of x on y. Here you, for your help to memorize, याद करने की सुविधा के लिए, you remember that x on y means if you are putting something on the table, means x is above y. So b is r, the correlation value, then put bracket, the standard deviation of, which will be above, standard deviation of x will be above the standard deviation of y. So SD x divided by SD y. So this is the formula of B. And this is the formula of A when the regression equation has to be computed in this form, regression of x on y. But when y on x, then B will be, B in this situation will be, can any one of you make an attempt? I will be happy. R into y on x. So
HDY.
standard deviation of y will be numerator and standard deviation of x will be denominator. रटना नहीं है. SD y divided by SD x. Okay. So this will be the value of v. So in this situation, you can calculate r is 0.5. So is equal to 0.5 into SDX is 7 divided by 8 bracket closed. I have missed some formula. So it is 0.44. Similarly, this is the B when you are computing regression of x on y. And if you are computing regression of y on x, then B will be is equal to, I think it is asking for some bracket. R is 0.5. Then y is 8 divided by 7, bracket closed, bracket closed. कुछ गड़बड़ हो रहा है. When it is red, it means there is something wrong. It is correcting itself. So this is the regression coefficient. So you have to compute b, and a can be computed in this way. But for computational purpose, this is the simplest computation. Suppose I am asking that if x is equal to say 37, then if x is equal to 37, then predict the value of y is equal to what? Okay, इसी में सब हो गया क्या? Then y is equal to what? So what we have to do, अपने को याद दिलाइए, we have to predict x on the basis of y. No, we have to predict y on the basis of x. So we will use this equation, regression of y on x. So if x is equal to 37, and we have to write this equation y minus y bar. So we have to compute y, we don't know, minus what is y bar? Y bar is 54. Put it in bracket. ये लिखा है ना, y minus y bar is equal to b into x, and x is given, x is 37. 37 minus x bar is 30. It is given. So what will be the value of y? Y will be is equal to b into 37 minus b into 30 plus, I will take 5 minutes more, plus this 54 will come this side, so this will be plus 54. And we have already computed b. B is 0.57. So putting this in formula, we will do y is equal to b is 0.57, 0.57 into 37 minus, let us put in bracket, 0.57 into 30, close the bracket, put one more bracket, plus 54, and then close the bracket. One bracket has to be removed. So if x is equal to 37, y will be 58. So you can do this type of prediction. So two questions will come. Either you will have to write the regression equation in raw score form, or you will have to make prediction. If you have to write the regression equation in raw score form, then y is equal to b into, so b is 0.57 x, this is the value of b, 0.57x plus b x bar plus e- sorry minus b x bar. I cannot write x bar, so x mean plus y mean, and we know the values, so this will be bx mean, so b into mean of x, so point is equal to 0.57 into the mean of x is 30 into 30, this is one value, and the another value is y bar, so we will compute y bar is 54, and this will come this side, and this is minus, so is equal to 54 minus 17.1. This is 36.9. So we can write the regression equation in y is equal to a plus bx form, 0.57 x, 0.57x plus 36.9. This is the regression equation in raw score form. And if you have been asked two questions, write the regression equation in raw score form and make this prediction. Now you can put this value. Ex is 37. So 0.57 into 37 minus, sorry, plus 36.9, it is 58. So if only prediction is asked, then this is the easiest method. इस फार्मूला से करेंगे तो आसानी से ये कैलकुलेशन हो जाएगा. But if it is asked that you write the regression equation in raw score form, then you will do in this way, and then you can put the value of x in this equation directly, and you will easily get the value. And look, both the values are same. So this is all from my side, and I am repeating that you have learned the correlation, regression, computation of product moment correlation, computation of bivariate correlation, and computation of bivariate regression, both regression of x on y and regression of y on x. And I hope you can easily write this equation without putting much effort. And then in the other unit, I have already covered chi-square. So this is on the syllabus for the examination. And if you have query, focus only on this. And if you have any question or query, you can ask. So I will stop recording here, and then I will continue for a couple of minutes to hear back from you if you want anything.